In the previous video lesson, you have learned the division algorithm and you also know that the use of division algorithm is to write a formula of a polynomial. Now we come to see how we use this formula in order to generate two important theorems in polynomial. The first one is called remainder theorem, and you can guess it is a theorem which helps you to find remainder in a very quick way. Do you remember how you can get the remainder of a division? Yes, you have to do the long division. It takes you quite a long time, right? Especially if the polynomial is not that easy, simple. But the remainder theorem here gives you a very quick way to find the remainder. And then let's take a look as follows. So it will be done by substitution in a function. When fx is divided by x minus a, and then now you can take a quick look, would be x minus a means, okay, x minus a here. You can consider x minus a is 0. That means you do substitution of x equal to a. And then it tells you that remainder is fa. And then the other situation would be when you have division of bx minus c, and now you have a rough work here. Bx minus c is 0, bx is c, that means x is c over b, and it is your choice of your substitution. And the remainder can be obtained by fc over b. Okay, now we come to see how we can prove the theorem as follows. It's quite easy. Now, once again, you can see that, okay, first one. But once again, you will see that I don't know what actually fx is and how we can find the remainder. True. But by division algorithm, you can roughly write down fx as is divided by x minus a, and then you have quotient, right? I don't know what is it, and that's why I write qx only. And you also have a remainder. For example, I call it r1. And then because the divisor is power 1 only, x to the power 1 minus a. So that's why I know that the remainder should be a constant. That's why I just write out. And then with the special choice of x equal to a, which I demonstrated before, that means now if you choose to do fa is equal to a minus a, qa, and then plus r1. Constant means that it won't be affected by the substitution, the choice of substitution. You put a, it's still r1 over there. Besides, you will see that I don't know what actually qa is because I don't know what is qx. But can you see that it is a 0 in the front? That means the whole term will be gone because it goes to 0. And finally, can you see that remainder will be your fa? And this is the sentence. What the theorem is telling you. Okay, number 2. So I quickly prove it to you as well. This time fx is divided by bx minus c, and then with a quotient again, and for example, I call it remainder 2. And then now, with our suitable substitution, which you see I choose c over b, and that means now f c over b equal to b, it's very big, b times c over b minus c, q c over b, very terrible. Okay, once again, R2 is a constant, and that's why it won't be affected by any substitution you choose. Whereas you have fc over b equal to, can you do it very quickly? bb is cancelled, which is c minus c afterward, and it goes to 0 finally. That's why even we don't know what is qc over b, nor qx, the whole expression goes to 0 already. As a result, it's remainder 2, or we will write it, remainder can be obtained by fc over b. This is the proof of the form of the theorem. It's not really a very hard matter to you, right? Now we go to, okay, what should I say? We rarely ask you how to prove the theorem, indeed. But on the other hand, we are asking you to use the theorem because we want to find the remainder very quickly. And then, so here it is. The same polynomial fx is divided by different terms or different expression, and you have to find the remainder. So that's why you have to make your choice first. Okay, so for example, like you have your rough work. Okay, x minus 1, that means you think of x minus 1 equal to 0, that means you choose x equal to 1. BC are too easy, demonstrate part D. 2x plus 1 equals 0, x is minus 1 over 2, while E will be 3x minus 5 equals 0, that means x is 5 over 3. These are some rough work you have to do beforehand when you want to find the remainder. Now coming up next, for A, how we go to find the remainder, it will be done by substitution of F1. And you can use the little letter R to represent remainder, as it is a well-known notation talking about polynomial. So it goes to 1 cube minus 2 times 1 square, that means 2 as well, plus 4 minus 1, and then finally, what is it? So it's equal to 2. Whereas D, it takes you a little bit longer time because you are going to substitution of minus 1 over 2, and that's why it's minus half cube minus 2 times minus half square plus 4 times minus half and minus 1. Finally, it's your job to find the answer, of course. A simple question can be found in example 14, in which when you have a division of divided by x plus k, you have the remainder. So that's why we are applying the remainder theorem to make an equation, as we are going to find an unknown, find the values of k, which is, okay, divided by x plus k, that means we are going to substitution of x is minus k in this polynomial. But we don't write f minus k here because fx is not mentioned in the question. It's better not to do so. And then as a result, how we are going to present it will be more direct, in which you put minus k into x, that means minus k squared minus negative k minus 7. And then it is what remainder telling you the outcome, and the remainder now is 5. So that's why we put an equal sign to in the question. And afterward, it goes to simplification problems, in which you have k squared plus k minus 12 equals 0. A little sense you should have will be when you have square, please be aware that it's very likely about solving quadratic equation. And then if you use your calculator, solve it, and you have k is, okay, let's wait. Okay, k is negative 4 or 3. And then when you read the question once again, there is a word as values over there. So it's very natural to have two answers in our answer. Finally, we come to the last example in this video lesson. So you will see now a big polynomial divided by 1 minus x, remainder is 5. Divided by 2 minus x, remainder is 29. So the only thing you will find a little bit different will be this time is x, not x minus 1, but 1 minus x. But the idea is more or less the same, in which you are going to substitute x is 1. Similarly, 2 minus x is 0, that means you're going to have substitution of x equal to 2. Okay. Secondly is, can you see that you are going to find two unknowns, m and n? So that's why you need to set up two equations in order to solve it. And which is, in the first one, maybe I put in red for the first one. Put the x is 1, remainder is 5. So that's why 4 times 1 cube minus 2 times 1 square plus m plus 1. And basically you put 1 for xe plus m minus 1 equal to 5. This is the situation you have. After simplification, check whether you obtain the outcome m plus n is equal to 3, which is called equation 1. In green, now you have the second one. Substitution of x is 2, which gives you 4 times 2 cube minus 2 times 2 square, m plus 1 times 2 plus n minus 1, which is equal to remainder is 29. So you take a short while to simplify very carefully, and it gives you 2m plus n equal to 4, which is an equation 2. If you have a program, then you can solve it directly, or else you can use elimination, substitution, other methods to solve it. And now I just mentioned saying that by solving equation, for example, I used a program, and m would be a 1 and n is a 2.